And welcome to 90 Notes, the iSchool version. Well, here we're going to go over the 10 problems that are on your iSchool exam for Module 8, first part. And, just to make sure you're getting them all right. I'll avoid giving you all the answers, but change the problems a little bit. We've got a cylinder. We've got a height, 5 meters. Its diameter is 4 times the height. Wow, that's a squat cylinder. So you know it looks a lot like this one up here. And we know the volume of a cylinder is pi r squared h. And again, you are just setting this up. And I believe the way they want you to put in the answer is with the substitution and the units. And I think they ask you to use, maybe you'll replace the pi with a 3.14. But you're going to put in, remember, take whatever the diameter is and divide by 2. Well, because your diameter, what did it say? It says a diameter is 4 times the measure of the height. So again, this diameter is 20. In this example, it's 4 times the 5. So that was the only thing you had to really figure out. But remember to switch back to radius when you're doing the substitution. So little tricks like that. That's pretty much all this you got to watch out for. How about the second one? Well, same kind of thing. Here I've got a diameter of 6 centimeters, and a height's 3 times the diameter. Well, 3 6s are 18. In my hypothetical example, your example will be similar. And we know the volume of a cone, 1/3 pi r squared h. Same thing as you did before. You're just going to show the substitution. So I think they want, and they want you to put the units in. Honestly, I think the units get cluttered, but you can see here, you're squaring centimeters, that's square centimeters, times centimeters again, and it's consistent. You'll have cubic centimeters. Pretty easy. And again, this one was 6 and a height. Well, okay, and that's enough said about that. Let's move on to number 3. Now, this is the one you're probably really interested in because for once you got to work backwards or do something a little different. You're given the volume. I made a little picture for you here. It's got a height of 12 inches. Now, instead of using, I'm just going to use a capital B for area of the base because I find that to be much more consistent. And let's just substitute some numbers in there. And I'll even use the units because they like to do that. Now, I know what my, what my volume is. And now what I'm going to do, 1/3 area of the base times the height. And I can go 2 different ways here. I could either, in the blue here, I could multiply both sides by the reciprocal and then solve it. Or in the green here, I could take the 1/3 and the 12 and make that into 4. Either way, when you solve this very simple equation, then you're going to come up with this. That capital B, that's the area of the base, is 256 square inches. Now, since the base is a square, well, I guess you're going to take the square root of that, won't you? You should recognize that number. That number is a perfect square. Well, of course, it's a perfect square, but it's also a power of 2. Anybody recognize it? Remember, we memorized the first 25 perfect squares. See if you can find that. And of course, the square root of square inches is just plain inches. Number 4. Oh, this is the one that really gets me. I looked at this problem over and over and over. I know this is what they want you to do. They're imagining, I've got this little cylinder here, and it's filled up in this example with 8 inches of water. Now, I read this over and over. They say 4-inch diameter. Now, you've got these little marbles, I guess they are, 3-inch diameter. You're going to put 6 of them in there? I don't think so. Look at the picture. I guess somebody's not really proofreading these very carefully, but this is what they were asking for. The volume of the water is the volume of the cylinder minus 6 of these spheres, which really wouldn't fit in there. But your author didn't know that, so let's just go ahead and put that in there. Now, you'll sometimes see me use a capital R, and a lowercase r, and that's for the big radius and the wee radius. And in this hypothetical example, I think we came up with something like this. Again, you had to take the diameter, convert it to radius, and this was another one where we're just substituting. We didn't come up with an answer. Now, to make sure they didn't screw up, I did work this out, and it does still come out a positive number. Thank God, because if it was negative, that would be terrible. But you've got 6 over here. You can see you've got 6 spheres, and the spheres are 4/3 pi r cubed. The only thing you had to remember again was to convert diameters into radii. But I have to laugh looking at that picture. Anybody else notice that? No, that's the fun. That's the fun of going through these tests. Okay, now this one we can do. And, it looks like we've got this little, just another setup problem. How easy is this? You've got a diameter of 4. They're always giving you the diameter. Golly, all you got to do is that. I'm going to call this H1, H2 for the 2 different heights. Well, remember, pi is constant. The radius is the same. Honestly, I would factor these out. But that's not the way they want to show the answer. They want you to show your answer something like that. Substitute. You're going to substitute the radius twice, same radius, and you're going to use the first one height, and you're going to have to indicate subtraction to find your other height. And honestly, easy squeezy. But you already know that because you're just adding the volume of a cylinder and a cone. Okay, number 6. Oh, finally. Gosh, I love this one. Hey, let's do some solid modeling for once. I've got this pipe here, 8-inch diameter and a thickness of 3/4 of an inch. So for all you good engineers, and maybe in your notes, you might want to do this. You can draw it, and this would be your auxiliary view. And you can say, hey, that's there you go. There's a diameter of 8. That's going to give you 2 different radii. Now, your 3/4 inch, well, if you just subtract 3/4 from 4, you're going to have a different radius. You're going to have a radius of 3 1/4. Now, what did we say? This was 20. That's right. So let's take this shape. Oh, and by the way, this shape is known as an annulus. Your author didn't ask about that, but that's just kind of fun. When you have the area between the 2 concentric circles. So if we were to take this and we were to take that annulus and give it some depth, let's say, they said 20, there we go, 20. And then we'll just have to zoom it back down, or maybe like that. And there you go. You can see the shape, and it's a hollow pipe like that. Looks like that. You can look down it like there. And honestly, it'd be more fun if we were actually making these shapes. And if we were back in the classroom, we'd be doing this. Sorry, everybody, but hope that pandemic's over soon so we can get back to some real math. So, all right, let's go back. Let's just do the arithmetic here. I'm going to go back to the still drawing. I'll move this one out of the way. And so the volume of the outer cylinder minus the volume of the inner cylinder. Again, pi r squared h in each case. And I'm going to factor, went off the page there, sorry. And that's it. Now, remember when you're putting this in there, what's the first radius? You're going to replace the big R with, well, 4. And remember, that one's going to be 3 1/4. And the height is going to be the same. And incidentally, r squared minus r squared times pi, that expression is the annulus. And the annulus times the height gives me the volume of that pipe. And but I'm going to let you do the arithmetic because that's why you're here. So get on it. And why was 6 scared of 7? My favorite joke. Why? Because 7, 8, 9. Oh no, not the density problems. Ah, the density problems. We don't cover this in our textbook, but it's in this unit. So we're trying to find the density, and I know they got you these things here: density, equals mass over volume, etc. You can just take these two phrases and move them around till they make sense. If I put this and I put this one on the top, that doesn't make any sense. I'm thinking I can imagine cubic inches per cookie. Doesn't make sense. But if I took it this way, if I said, well, how many cookies do I have per cubic foot, let's say? Now that sounds like a density, and that's consistent. That's consistent with what we have here. Well, I guess in this case it's mass and volume, or you could say the number of cookies per per cubic inch of the tin. That makes sense to me. Let's try number 8. And again, I want to mention dimensional analysis again. You were told about all these things. It makes me chuckle a little. They're throwing around the term weight, and I know your physics teacher is going to be saying, I want to use mass, but we'll save that for the physics class. And we're going to say, well, what do we do here? We've got, says we've got exactly 20 or 202 milliliters, and we've got a density. Watch this with my dimensional analysis. So I'm going to take this, and I'm going to multiply times this density. Well, piece of cake, because I know it's going to, look what happens with the units. That's your dimensional analysis. The units drop off, and you are left with grams. And you can multiply these two numbers together. I don't think I have to do that for you. You're going to multiply them together and round them to the nearest hundredth and put your answer in there. What would the unit be? Of course, the unit, your answer is going to be in grams. And again, is that going to be consistent? Yes. Mass equals density times volume. Oh, and by the way, I believe you end up not having a round. You can just see by this particular example. Your answer will be in the hundredths place. So you can do the arithmetic. All right, 9. Oh, large emerald, blah, 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 blah. Oh, but okay, we got these 3 equations again. This time we want the volume. And you remember from Algebra 1, oh, by the way, these were just called literal equations. I could just take these equations. I could just know one of these equations and rearrange it to make the others. You probably remember that from Algebra 1. And so now let's say we're trying to find volume. And that's going to be mass times density, divided by density. That sounds silly. But if I were to take the mass, if I'm going to take this, this 378.24 grams, I want to get rid of that equal sign there. And if I'm going to take that and I'm going to divide by density. Now, dividing by density looks weird. So we know that if I divide, that's the same as multiplying by the reciprocal of the divisor. A little bit of elementary arithmetic for you all. And again, our dimensional analysis comes through. And what are we going to have? We're going to end up with an answer that's in cubic centimeters. So what do you have to do? Well, clearly, if you're, we did this to set up the problem. So I'm going to take this number in red, divide by the number in green, and your unit will be in cubic centimeters. Easy squeezy. All right, and one last one. Heavens to Murgatroyds, we've seen this like 3 times now. So, you already know what the answer is, but let's have a little fun with this. We're going to do this 3 different ways. And this is how we would be doing this in the class. I want you to explore this. We're going to take this triangle in this particular plane, and we're going to revolve it around this circular path, and of course it makes a cone. No surprises there. But what if I took, hang on, not that one. What if I took this? Just so we should know our other options. How about if I took this? I take this rectangle. And what do I get then? I'm going to do the same thing. I'm going to revolve it around a path. And of course, you all know that you get the cylinder, which is kind of cool because a cylinder can be extruded or revolved. That was the point of that. But now, let's do this. This one is perhaps be more interesting. Let's do this instead. Let's take this rectangle. Let's cut it right there. And now, I'm going to take this figure, I'm going to cut this away. Now let's take this figure and revolve it. Oh, come on. I said we're going to revolve it. Whoa. Uh-oh. Hang on. Danger. Let's get this right. Okay. There we go. And now we get a far more interesting shape. And you can see that we get the cone that's inside the cylinder of the same height. And this will help you visualize. That's your 1/3. That's your 1/3 volume. That cone has the volume exactly 1/3 of the cylinder. A little bit more than they asked for, but I think it's a little bit more fun too. So everyone, I know this was not a very hard test for you. You're all geniuses, and make sure you just keep moving along on this iSchool. And I want to say thank you for watching Naughty Notes.